Okay, so we have several groups that are not presenting today. We have Jake and that is out, and so he's going to present next week. And I knew that was going to be a problem. He emailed well ahead of time, and I agreed that that would be fine. And we also have 2 students from San Francisco State University, Marcos and Paige. And so next week we'll get 2 presentations, but that means this week we should have 6 presentations. So that should work out just fine. Another thing that's happened this week is we have University of California at San Diego joining us for the first time. So hi, UCSD, we're really excited to have you. I talked to them briefly last night to kind of fill them in that you guys had all been working on mock DataJam projects, and they were excited to join tonight to see the mock DataJam projects. Students from UCSD, we're going to have a discussion after each project because we only have 6 presenting tonight. You have about 25 or 30 minutes per project, so we can have a really good discussion, not only about the project, but what you learned from the project and what all of us can learn, because the whole reason we do mock DataJam projects is so that you kind of have a hands-on, first-hand knowledge of what it's like to really try to do a DataJam project. And you run into problems with all sorts of things, and these are the exact same problems that DataJam teams run into, both the high school teams and the community college teams. And so this gives you a very good grip on how do you guide them, because you'll know firsthand exactly what it was like to try to do a project like this, where you had problems, where other people in the class had problems, and how they went about dealing with it. So we're really looking at this tonight as a really good educational experience for everybody. We're not judging you per se. However, when your teams present, they do get judged, and you remember that they get judged using the rubric that's available either in the high school DataJam guide or in the community college DataJam guide. And there's a rubric for the presentation and there's a rubric for the poster, because in DataJam projects, the posters get reviewed when the students aren't there. And then the presentation, the students are there presenting. Dr. Siopodos and I are going to kind of keep track of these rubrics, and we'll give you feedback. But basically, you'll get full credit for having done a project and got up and presented it. We have full faith that you'll actually learn a huge amount from going through this process. But I thought it would be valuable before we get started just to go over what the poster rubric is. All of you, though, have access to looking at this. So the first scoring category for the posters is to uncover and use a variety of data sources. So what the judges are looking for is that the team found data sources that would really allow them to answer their question, that were relevant to their question. And they give you ideas for what is a 5, highly competent, what is a 3, and what is a 1. A 1 would be too few sources and some were not pertinent to the question, whereas a 5 would be they were varied, they were high quality, they were pertinent, and there was sufficient data to answer the question. The other categories are form a research question based upon relevant data, analyze data and information, and data visualization. And then draw logical, definable conclusions, and communicate clearly and effectively. What are the findings that they got, and what did they conclude from the findings? So that's how the poster gets judged. And we're just going to move over and quickly look at the presentation also, because tonight you're going to be presenting the poster. So you would kind of qualify for both rubrics. So effective communication, and what they're looking at there is, do you do a good job going step by step through your project? If you made slides, and in your case, we don't have slides for this one, those would be judged, and answering questions. So how effectively are you able to answer questions? And does everybody on the team participate in the presentation, so that it wasn't just one or two students doing it? Everybody on the team is able to explain some things and is able to participate. So you want to keep that in mind. I'm looking for volunteers. Who would like to start? The groups at Caldwell and at San Francisco can share your screen and project. I have all the slides downloaded here, so the groups in Pittsburgh can project right here from the computer. You're probably going to want to enlarge the section of your poster that you're talking about. So volunteers for starting. Okay,
I guess
go
you can.
for it. Oh, you can be next. Who was that?
This is Adrian from
Adrian and John.
Okay, perfect. You're second. Okay, why don't we go forward?
Wait, how do you zoom in on camera? I think she was open there. Oh, she's
Okay, here's your poster. You can just stand here and you can enlarge it to point out things. You have about 10 minutes to present. That's what the judges would give an actual DataJam team. And then everybody chime in and ask questions. And we really want to have a good discussion. So this is a good learning experience.
Hi everyone, my name is Bhaskar.
I'm Leon.
So our project was basically looking at the Pogo bike share program. So for those of you who are not from Pittsburgh, the Pogo bike share program is basically like City Bike. If you've ever been to New York, it's basically you just rent out a bike and you can ride them for, in this case, 30 minutes. You can basically just pick it up at any dock, ride it to any other dock. We do have like a map here of sort of all of the stations, which we'll kind of go into more detail when we get into our data. But just, you know, if you're not super familiar with what a bike share system is, that's really just the basic premise of it is you pick up the bike and then you just ride it wherever you would like to go. A lot of people use this for commuting and things like that. So our question was sort of, what are the most popular stations in the Pogo system and how does that vary between members and casual riders? So one thing at Pitt here, at University of Pittsburgh, all Pitt affiliated people, so that's students, that's faculty and staff, get a free membership. So that's 30 minutes, either an electric bike or a normal pedal bike. Unfortunately, this data set did not categorize between those who are Pitt members and those who are just like members, because you can obviously just pay an annual fee to be able to use these bikes. But that was sort of our question, is seeing the difference in most popular stations in the casual riders and members. So we hypothesized that the most popular stations for people who do have that membership will most likely be around the neighborhood of Oakland. Again, that is where the Pitt campus is. And we hypothesized that because of that free Pitt membership. And then for the casual riders, we expected the most popular stations to be near downtown. And our reasoning for that was kind of more tourists coming into Pittsburgh. The most popular areas to go are downtown, North Shore, sort of where all the attractions are, and people are just going to want to pay a one-time fee, bike around. There's lots of nice bike lanes down there, so that was sort of our hypothesis like that. Let me see if I missed anything in the background. So yeah, if you are not a member, you can just be a casual rider, which is you just pay a one-time fee, and that is how they're coded in that system there. And sort of the importance of this is, especially near the University of Pittsburgh in this neighborhood of Oakland, lack of available bikes. So like, let's say you take out a bike and you want to put a bike back in a dock. A lot of those docks end up being full. So then, you might go over the time. That becomes a really big issue. And then also empty docks. Let's say you're trying to get to class, for example, and then you want to take out a bike, but there are no bikes available. So that is a huge problem that I think a lot of people here at Pitt have noticed just around the university.
Yeah, you see like bikes like all around, like not even in the stations.
So I'll zoom in for you, and you can.
Oh yeah. Oh, I can try it too.
Okay.
Yeah, cool. So yeah, here's our map. We actually use data from the WPRDC, which is what recommended by Steve Saylor
Right.
last lecture,
Last class.
actually.
Yeah.
Pretty interesting stuff. Yeah. So you can obviously tell it's divided by different colors, like here. Pretty interesting. We basically put the data set into R. We then put it into like the head function, which basically plots, not only plots, but it divides the data into the 10 most popular stations in this case. And of course, we divided the data by stations. And, well, not by stations, by actual member type. So casuals and members. But the interesting thing about the R data set is that it's originally by duration, but we use the summarize function in R to calculate the number of rides. And if we actually look at the real data here, for casuals, it's the most popular station is the one in North Shore and Fort Duquesne. That's the one near downtown. And that's only about 100 rides. And if we look at members, that's South Bouquet and Senate Street, which is of course in Oakland.
One thing
And
to remind
that's
you,
3,000
this data is only for August 2024.
24.
Yeah, I want
Yeah.
to clarify that.
Yeah. And if we actually scroll down here, now this data set, we use a different data set here. And this is the POGO station locations, again from WPRDC. And this data set's actually from October 2023. However, even though it's a different date from our original data set, we still merged the data together because there aren't many differences. There's only like
They
one
didn't-
small difference.
They haven't added any stations since October 2023.
Oh, they added
there's
actually.
no new stations,
there
all
was
the
just-
same
oh,
stations.
Oh, okay. Oh, okay. Well then, okay. But they do have like one extra point here that's not mentioned in the map here, and this is actually a station located in Lawrenceville and Stenton. So that's 52nd and Butler Street. Just something interesting to mention. But again, in R, we actually overlaid the two maps. So this is the POGO 2023 map, and this is our geospatial map that we use. And in R, we just converted the spatial map into a stationary object, spatial object, merged the data, and then plotted it as it is seen here, divided into casual and members. It's also important to note that this is the longitude axis, and this is the latitude axis. Longitude axis is negative, so that's why 79 is here and 80 is here. Of course, negative 79 is greater than negative 80, as we all know in math. And to kind of summarize the data here that's shown here, the center region comprises of stations near Oakland, obviously a demographic to Pitt students. If you look at the extremes, westbound, that's the ones in downtown, of course, mainly casual riders.
You make point on the map.
Oh, yeah,
where
right here.
downtown is
Oh, yeah, yeah.
versus where Oakland is, because we have a lot of people.
Not on the,
It's-
yeah, can't see it there. That's true. So here, that's westbound, so that's downtown, includes North Shore. Here, this is eastbound. This includes Squirrel Hill, sorry. That includes Point Breeze, Shadyside, and Highland Park. Southbound includes Hazelwood. That's near Greenfield, near south of Squirrel Hill, near CMU, close to Oakland. All the way north is Lawrenceville, again, near Stenton. Kind of a different location. Very
Where's
kind of
the
score location.
University of Pittsburgh?
University of Pittsburgh, oh, obviously in the middle. Oakland.
Right.
Yeah. I guess that's kind of all you want to know, but it also includes other locations in the middle. You got Southside and you got Bloomfield too. And if we want to like talk about the whole members versus casual riders dilemma, if we look at the actual averages over here at the bottom, it's about 400 rides for members and 30 rides for casuals. So basically, members is over 100% of casuals. There's a big discrepancy worth mentioning. And then conclusions.
Oh, you want, okay.
Okay, yeah. So for conclusions, again, our hypothesis was that most popular stations are going to be in Oakland. Downtown will have many casual riders. And so that was pretty much correct. But again, it's really important to go back to the map. And it's not just Oakland. It's not just downtown. It again includes South Side, Bloomfield in the center, Oakland, that's where the U Pit is. And it also includes downtown, downtown for casual riders. That also includes the South Shore, East Allegheny, and it includes Allegheny West, and the Strip District 2 on the westbound. So again, that's for casual riders, this area, and this is for main riders. Pretty much signified by the blue dots. You can't really see many red dots because again, members pretty much eat up casuals. And Bhaskar can go for the next section. Challenges.
Yeah, so that's sort of, that's really what's important to consider. I mean, even if you see on this graph, and again, this is only for August 2024, it's just the sheer number of members who are taking rides compared to casuals was definitely not what we were expecting. I was definitely expecting a lot more casual rides, not as many as members, but certainly I figured that tourists would be renting out these bikes and stuff like that, but that was definitely not the case. So one of our challenges, which I kind of briefly mentioned, was this data set that we did have, which was the publicly accessible Pogo data set, didn't have a lot of fields recorded per ride. So for example, it would have been nice to be able to distinguish between pit members as well as normal members. I mean, we can probably assume that a lot of these members do end up being those pit members since it is a free membership and a lot of people do use it to commute between different locations and getting to class. But it really didn't have a lot of fields, so we were kind of limited on what we could ask in that regard. And in terms of recommendations that we have from our results, basically first, like future plans, this project really would be better expanded looking at other months. Obviously, this is just mock DataJam project, did this in a couple of weeks, but definitely this could be fleshed out to considering a couple of other months and maybe even, extrapolating that for years. And we also recommend increasing the number of docks and or stations near Oakland. As you can see, those are really, really congested both by the data, and you can also just just seeing, walking around Oakland, it gets really congested, and certainly this supports that. And additionally, what I was talking about, those casual members, how there were so much fewer than we would have expected. We think that Pogo could definitely be advertised to tourists more often, or people who might just want to use Pogo a couple of times and not shell out the cash for an annual membership. So anything else you want to add, Leon?
Oh, yeah. So I'd actually recommend putting some stations in Squirrel Hill here. You see so much space here, there's nothing. This is crazy. I see nobody riding bikes in Squirrel Hill too, so that's pretty lame. And same in South Shore, no bike stations here. And even at the northbound extremes and southbound extremes, there's barely any stations. You can see there's not too many stations. But hey, it's a big improvement. In 2022, there weren't many stations to begin with, as seen by the kind of yellow teardrops here. Of course, they signify the locations, but they added so many of those yellow teardrops now. So overall, it's a big success.
Mm.
Yeah.
Yeah, they've been expanding. So definitely, we recommend continuing the expansion in those areas. But yeah, we're open for questions, I guess.
Yeah.
Good. I'm going to make sure the chat is there. Sure. People online can just ask questions, and we also have the chat open. So you're very welcome to write questions in the chat. Questions here?
Oh yeah, go ahead.
I'm curious to note, as a resident of Shadyside who frequently gets the petitions for more bike lanes in Shadyside, does the bike lane, did you look at all whether the accessibility for biking changed, where was similar to where stations were placed? Because, for example, it's sometimes it's a very dangerous trek to go from downtown to Oakland or vice versa, because it's a major highway. Yeah. And so that might be why there's the disconnect between the two areas.
You know what? That's probably true, because you only see But real new bike lanes in Pittsburgh and you don't really see them in Shadyside or other regions that are not in the middle.
Yeah, I can answer that from kind of my own experience. You're kind of saying like you're thinking that they're changing stations based on like changes in accessibility, so like adding more bike lanes.
Or even just like there might be like, so like you said, like a lot of Pitt students and faculty are probably going to be located in or around Oakland as close as possible. But as you move to Squirrel Hill, there's less bike lanes. And so you would expect it to be harder for people to move around on bikes. So less casual people that aren't associated. As you said, the membership might be inflated due to Pitt being there. Like I would think if there are similar numbers of bike lanes in the areas where maybe those stations aren't, but you still see casual members, that it might be bike lanes might have more.
Yeah, absolutely. I think that's definitely important to consider. That's kind of why we were expecting more popularity with the casual users near downtown and North Shore. If you are familiar, like there is a bike lane that goes actually all around the tip of Pittsburgh here. It's called the Three Rivers Heritage Trail. There's even a trail here starting from the Point that technically links up all the way to Washington, D.C. So really, I expected a lot more casual riders in these areas. I definitely agree, like Oakland, I mean, even Oakland can improve with more bike lanes. It's kind of treacherous even to bike there, and definitely in Shadyside, but I think that definitely is important to consider. I think another thing is year to year, like if we were doing this year to year, I don't even think we would see that many differences in all honesty, because they don't add the bike lanes that quickly, at least as long as I've been here, which is only like 2.5 years. So, but I think in the long run, I think that is important to consider based on casual ridership. But yeah, thanks for the question.
Other question.
So what variables did you have in the data set? So what are the information that you had?
You want to answer?
Oh yeah, go ahead. Yeah, go ahead.
So you had information about the number,
Yeah, the numbers
people that they
arrives. Yeah.
okay, and the time. That
The
was
type,
the data
rider
set
type.
basically?
Oh, it's the stations and the number of rides mainly.
It measures each individual ride.
Did you have any other information in your data?
Member casual, that's it.
Remember casual, yeah.
Yeah,
But
so that
it
was sort of
didn't have time of day or anything like
It
that.
had duration, which was
duration. I don't think did it have time of day?
It had duration, but
Only
it didn't have
duration,
time
okay.
in no
Yeah.
time of
Okay.
day. But we used the duration to again calculate the number of rides. So that was like end to start. Maybe it didn't include the time because it included the start and end. But we used the start because that's actually calculates the number of rides. You wouldn't use the end. It's like just using a shopping cart, right? Not everybody puts the shopping cart back.
Right.
Because definitely, if you had more variables, you could also explore something more, right? So here, what I observe is that you have kind of two categorical variables. One is the biker status, whether they are like members or casual, right? And then you're also interested to see if they're downtown or in the university area. So usually, if you want, let's say, to explore relationship between two categorical variables, there are some statistical methods that you can apply. Like high square test for independence. So that test basically will tell you if indeed there is a relationship between the status and let's say the location of the background. Okay, so that was great. It's like you're giving you like a very detailed exploratory data analysis, but there are also like statistical methods where you can basically apply them and see if indeed there is a statistical difference between these two.
Yeah, that's something I was talking about, Leon, with this, is we definitely could have done some more statistical tests. This really was sort of like a first step. Like, I agree with you. This was definitely very much exploratory, but yeah, we were definitely thinking of some significance tests. I think that's one way this can be made more, a little bit more specific.
Some more variables that you could use to improve your analysis.
Well, if that
you
data
may
set,
consider.
yeah, if that data set did have time of day, I think that could definitely be considered. Although I'm a little bit hesitant to make a hypothesis with time of day, because it's not like you could just, say during rush hour or something like that, because students will use it at all hours of the day, but you could.
What about if you had duration of the ride?
Oh yeah, we did, but
You did have the duration of the ride.
oh, we did have the duration. But we
Then
didn't
you could even
summarize.
apply a regression, right?
Oh,
If you have the duration, you can have that as response, and then you can have different explanatory variables, right? Then
I see the point.
the biker status or any other information, and then see if there's a relationship between the duration of the ride and let's say.
How would you use the statistical test for Like, what would you try to find with a statistical test?
So the chi-square test that I mentioned. So
you
these
mean
you need to
chi-square?
see yes chi-square test for independence. So you want to see if there is an association between the status and the location.
Data is
Yeah.
location.
So then let's say the status where the member or casual, and then the location where you're downtown or I don't know in the university area, something like that.
It tests the strength.
Yes, it's called chi-square test.
Are there other questions from people online?
Yes. Have you encountered any issues when trying to get and format data? Can you just talk about like how you've sort of formatted the data, any challenges you had there?
Not really many challenges. Because again, the data set was from WPRDC. So we just read it in through the read CBSV command in R. Then we use the duration to summarize the points to count how many writes there are. And then we use ggplot to make the bar graph here. And the geospatial plot, which we use another data set to merge the data and make that plot. So it was pretty easy.
So a very nice thing about the Western Pennsylvania Data Resource Center is they clean the data before they post it. So
yeah,
you have
that's true.
very clean data sets because I think this question is a really good question and many data sets that are publicly available have not been cleaned anywhere near as well as the WPDRC have been cleaned. So it's a great question, and cleaning the data and having to work with it before you get to use it often happens.
Okay, another question is, as a Pitt student who uses the Atwood Bates Pogo Station all the time, this is a really cool data set to look at. I wonder if the reason why casual trips are less common is because bike lanes are less prevalent outside of Oakland. Exactly what you said, so yes, I definitely agree with that. I think the city can improve on its bike infrastructure a lot. And then what other variables would you have liked to include? I think we also talked about that here, such as time of day or weather. Weather would be a little tough, I think. I think that would be a little tough to do, but that definitely is, that's a possibility, yeah.
Yeah, you could have done weather if you had had the time that it was, but you had the duration without having the actual time.
Yes.
You would have obviously had to get weather off another data set. So I think in the sense of trying to really learn take-home messages from this that you'll apply to working with teams you work with, do you have a sense of a take-home message or two that you learned?
Yeah, I think for me definitely is doing some more advanced statistical testing, I think. I mean, considering that this data set was a little limited, I think that's sort of the next logical step is not only expanding it, obviously this is just 1 month, and also August 2024, Pitt wasn't fully in session until the end of that month, so I think just combining more months, I think that's one takeaway message. And then the second is, yeah, definitely applying some more statistical methods such as a chi-square test.
Yeah.
You have anything?
Yeah, definitely use the duration to find more variables, find more confounding variables. Maybe use the weather as a variable too. That's pretty much it. I mentioned
You could even apply logistic regression. For example, you may want to be able to predict if they are casual or if they're members based on some maybe demographic information. Again, you can apply a logistic regression. You can do a lot of things if you had more data.
Yeah.
Well, very
I also
nice.
have two more comments.
Okay, go ahead.
So on the poster, so you mentioned bar graph, but actually you have box plot there. So it's not box plot, it's bar graph, right? So these are bar graphs, not box plots. I think on the second line you said these box plots, but these are bar graphs. You
typo.
mentioned bar graphs, you just wrote like box plot. And then another thing is we need to be careful with the imbalanced data in different categories, because you may get quite biased results. So you said you have 300 something in the members. Can you go down?
Which one? You mean
Going
the...
down, so yes, but 395 that they're members,
Oh,
and
I see.
only can't see the number. Maybe 60 that they're casual.
30.
I don't know.
Yeah,
30, yes.
30. So you need to be quite careful about imbalanced data because you may get inaccurate conclusions.
What do you mean by...
So you see, in one group, you have around 400. In the other group, you have 30. So that's a quite big difference in numbers. like 400 to
So
30.
you mean like choose variables that are more closely together to make it more
Well,
accurate?
or just take it into account. I mean,
Yes.
you can't do anything about
Yes.
the fact that
Yes.
there's many.
There are techniques that kind of resample some. But
Oh,
there's- you
I
need
think
to
I
be
get what
careful.
you mean.
need
Yeah,
to be
yeah.
careful about those the
Right.
balance between the categories.
Yeah, I understand. Yeah.
Thank
Okay.
you.
Yeah.
Thank you.
Some points.
We're going to stop sharing here.
That's pretty good.
If I can figure out how to do that. Oh, not stop recording. No.
It's the
No.
view. Share content is the one, and then stop sharing.
Okay. Okay, great. And we had another team that volunteered, and I don't know who that was, but whoever volunteered right at the beginning, you can share your screen and tell us who you are.
All right, sounds good. Hey, Adrian, can you share the screen?
Yeah, I'll share it.
All right, perfect. So, hello, let me know when it's ready.
Yep. Well, we don't see your screen yet. Here it comes.
Can you
Okay.
see the PDF?
Not quite, but it looks here now. Yes.
Okay, okay, perfect.
Yes.
Okay, so hello, my name's Adrian, and this is Jiang. The title of our poster is The Relationship Between Government Funding and Homelessness in Oakland, California. Homelessness in California has become a big issue in the Bay Area. The rise of unhoused individuals is a concern to many Californians and Bay Area residents for various reasons. For example, the drug use, the crime, violence, and the increase in trash and despite financial support from groups like the Department of Housing and Urban Development, we are still seeing an increase in homelessness. And this has us wondering where the money goes, where the taxpayers' money goes, and also the effectiveness of the current strategies and how much the city of Oakland is funding is being allocated towards actually addressing homelessness. And understanding this spending is crucial for evaluating the city's efforts and identifying the gaps in its approach. So our research question is, how much funding has the government allocated towards addressing the homelessness in Oakland? And what is the relationship between the funding and the changes in the number of unhoused individuals over time? And from there, we decided that our hypothesis is that an increase in government funding will not significantly reduce homelessness in Oakland, suggesting that factors beyond financial investments are contributing to the persistence of this issue.
Okay, so for methods, we did exploratory data analysis using the graphic tools in Excel. So to look at to have an initial understanding of the data set, and for the visualization for the relationships between the government funding and homelessness, we apply linear regression, and this is our graph for that. So let's first look at our data set. So this is a quite small data set. We have 6 rows and 7 columns. And the columns are enrolling homeless people enrolling for the first time and people returning to homeless. And people have found temporary destinations, and people have found permanent destinations, and total number of people experiencing homelessness, and median estimated spending by the government in millions. And the last one is the range of the government spending in millions, because some of the data is not shown in the government website. So we took the range and chose the median of the spending as our data for the spending. for the government fund. And for the years, we have we're analysis we're performing analysis on the data from 2016 to 2020. But we added 2015 there, so we have the initial number of homeless people here, and then we did some calculation to add it up for the rest of the years. So over here are the graphs as for enrolling for the first time, returning to homelessness, temporary destinations, and permanent destinations. As we can see, all of the data for the people for all four categories, they're all increasing over time from 2016 to 2020. And also we have the graph for the median estimated spending. And the spending from 2015 to 2020 has also increased over years. In fact, from 2015 to 2018, they increased about $10 million a year. And from 2019 to 2020, there's a huge increase, as we can see here. And here's our linear regression for the amount of homelessness people versus the median estimated government spending. As we can see here, the more homeless people we have, the more the government funding, are allocated to them, but are they really using them towards homelessness? We don't know. Now let's look at our findings. So the number of individuals enrolling for the first time in homeless services and those returning to homeless services increased consistently from 2016 to 2020. And while the number of people relocated to temporary and permanent housing destinations also rose during the same period. And the rate of increase was lower compared to the increase of the first-time enrollee and returnees. So the rate of increase over here is lower, which means we have more people going into homeless than people finding the permanent or temporary locations, residents. And government funding at addressing the homelessness issues saw a significant increase between 2016 to 2020. And with the last increase from 2019 to 2020, almost doubling the size. As we can see here, in 2019, the government funding was at $69 million, and in 2020, it's at 120. And the one thing I want to point out is for the temporary destinations, we see a huge increase from 2019 to 2020, which, well, if nothing special happened, it should be a good thing because we had a lot more people finding temporary destinations. But that's actually not the case. That's because of COVID, the government has to get some people off the street. So that's why we see a huge increase over here. And for our linear regression, we have the multiple R at 0.95, which means there's a strong relationship between the strong correlation between the total number of people experiencing homelessness and the government funding, which means strong positive correlation, which means the more homeless people we have, the more funding the government needed to solve the problem. And we can also see the coefficients and the intercept coefficients for the intercept and x variables. So every time the total number of people experience homeless increased by 1,000, the spending will increase by 10 million. over here. And then we go to our conclusion. So based on our analysis, we conclude that the government funding for homeless between 2016 and 2020 has not resulted in a corresponding reduction in the homeless population in Oakland. And in fact, despite nearly doubling the spending, the financial resources to solve the homelessness issue, both first-time minority and returnees continue to rise over the years. And although there's a increase in the number of people relocated to temporary and permanent housing destinations, the rise was outpaced by the growing number of homeless individuals, suggesting that the rate of people falling into homelessness or returning to it exceeded the system's ability to provide long-term solutions. So with the increased government funding, they still can't solve the problem. And Adrian will address the challenges we had.
So we did face a couple of challenges. So most of the data that we found were basically on the resources, which is oaklandcalifornia.gov. And some of the challenges that were tough were that we weren't unable to find data regarding like the reasons why most people become homeless. Again, there weren't any CSV files, or that the CS files that we did find didn't have a lot of details of what we were hoping to get. And again, we were not able to find how the money was being dispersed. I think that was another issue with nonprofits, because nonprofits in California don't really have to show those numbers. So again, these type of things gave us insufficient information. And yeah, that is it.
Yeah, and here's our resources.
Very nice. Very nice. So we'll take questions. You can just say your question, or you can write it in the chat. Do you guys have the chat open?
Yeah, I have the chat open.
Let me open.
Great.
What recommendations would you suggest for this research question? I think it's better to find the data first, because it depends on the state, but it's very difficult to get the data. I do believe that it would be easier if we would go to these nonprofits or the Alameda County and ask for the data there. Next question. Do you think the missing data significantly impacted your conclusion? I wouldn't say that. I guess.
I feel like the I feel like the government, they are, well, whenever they talk about the people they helped, like people return, find permanent or temporary locations, they would put the number on there. But for those going to homelessness, it's really hard to tell like exactly how many people there are, because not everyone's enrolled in the system. But
so how did you treat the missing data?
What we actually didn't have, the data we looked at was just from 2016 to 2020, and the only missing data was from total number of people experiencing homeless, because the government on the website, it has the total for like 3 years. But so that's why I added 2015 in here. because they had the data for 2015, and then I used their numbers to calculate the total number of people experiencing homelessness.
How did you use the numbers to get the total number of homeless?
So total for 2015 is 2191. So that's the official number. So I treated like all these 4 rows as official rows, like official numbers for people enrolling and people pretty much people getting in and getting out. So like I just added the total number with the people going in and deducted by people going out. That's how we did it, because we didn't have data for this. And even if we did, I feel like it wouldn't make sense if they don't match.
I think you have another question in the chat.
Do you think the data set precise? No, I don't. Well, for the government funding,
Can you read it? Because not everybody can see the chat.
so like for our I think it's precise to a certain degree, because
Yeah,
again, all the data is from our government website, and it gives us a range like for the
yeah,
government
like
spending.
I also feel that it would have been better like if we would get data set like data regarding the factors on why people become homeless, because there's multiple factors on why people become homeless, and we want to know where that money is being allocated to. Sorry, I have a stutter, but yeah.
Yeah, so that question was your data set precise? The people in Pittsburgh are not right near a computer, so you need to read the chat.
So I have another question. So if you have access to any data that you wanted to get, so what are the variables that you also consider? Apart from, let's say, why someone became homeless, do you think there will be other factors that they may impact the relationship that you studied here?
Yes, I would think so, because like there are, for like people going into homeless, enrolling for the first time and returning to homelessness, yeah, it would be really helpful to know the reason behind it, because why people became homeless in the first place, and why people went from homeless to finding a resident or somewhere to live and then go back to homelessness. I think those factors contribute to the problem.
You had mentioned that you would like to know why they became homeless, and I think this is an issue that frequently comes up in DataJam projects. Certainly publicly available data sets are not allowed to have identifying information. And so what happens is that people have very specific reasons, for example, for becoming homeless, but the government's very leery about making that available in their publicly available data sets, because they are under an obligation to not let people be identifiable. And this happens in all sorts of questions, not only about things like this, where you're looking at government allocation of resources, but also becomes a huge issue for any healthcare question. You can only get frequently mean data. You can't get individual data. If you do get individual data, everything will have been removed that makes it individually identifiable. And so that is a problem that all of you are likely to face as you are working with your DataJam teams. And there isn't anything we can do about it. I mean, it's good that things are not personally identifiable, but it's good for you as a mentor to keep that in mind. I think you have another question in here from San Francisco. Why do you think it was difficult to find data Oh, on reasons. I think I just answered the question for you. I apologize.
Did we answer the one before that?
Yeah, why
I
don't you
think we did.
read that one?
What
What
is
is something
something?
that you wish you knew before you started this investigation? And were there particular data sets you found later that were more helpful to answer your question? Again, I guess how difficult it is to find data for me was a little difficult. So maybe know where the data is before we start like an actual research question, because maybe sometimes it's just difficult to find the answers.
Yeah, I agree. I would like because me and Adrian talked about doing something about homelessness, like doing a project about this like a couple years ago. So we finally got a chance to do it. But like even before we start, I mentioned like it's gonna be hard to find the data set because like we had to manually find everything instead of okay, I could go to like Kaggle or whatever to get a huge data set for the project. So that's uh the difficult part. Like uh yeah, we knew it would be hard, but like we decided to do it anyways, and the data
Well,
set was not so complete. So well
yeah.
not that's
So
didn't have a lot of labels.
finding data sets is probably the most difficult thing DataJam teams run up against. And we try to make lots of resources available on the website. But the other really good thing for you to remember as mentors is you're forming a network. You have all of you in a bunch of different states, and you have links to faculty. And if you have a team that's looking for a data set and you can't find it, then send out an email. You have email addresses. Let people know what you're looking for, and you can get a lot of people brainstorming with you and your team. We're going to move on to the next presentation. I'd love.
Quick comment is on
Okay.
the sample size.
Okay.
We need to be a little bit concerned if the sample size is too small. We will not really be able to get accurate results. Okay, that's something that we need to have in mind. We try to find as more data as possible so we can get more accurate, results and conclusions.
Okay.
Thank
It
you.
would be great to have a team from New Jersey. Thank you, San Francisco. That was really fantastic.
Thank you.
Do we have a New Jersey team?
Yes, we'll go next.
Okay, perfect. You want to share your screen?
Yes, I'm on it.
Oh.
Thailand?
Can you see it? I'm guessing yes.
Yes, yes. Okay, you want to go ahead and start?
Yes, I'm just trying to get this out of the way. Okay. Shall I start?
Yes.
Okay, so for our project title, we covered, does physical exercise have any effect on mental health? And we hypothesized that a positive correlation between physical exercise and mental health would be seen because regular physical activity is expected to improve well-being by reducing stress and enhancing mood through the release of endorphins. And individuals who exercise regularly or consistently should show better mental health outcomes, such as lower anxiety and depression, compared to those who don't. For our data set, we utilized the data set from ORCID, ORCID, which contained data for high school students participating in a controlled environment. controlled experiment, sorry. The data set comprised information from two groups. It was one a control group and the other that was just a regular group. And the purpose of this experiment was to evaluate the impact of physical exercise on their mental health. Key metrics such as test scores and physical fitness levels were collected to compare the outcome between the two groups, the control group and the normal group. And yeah, Suman will take it from here.
So, actually, I would do the analysis part, and someone would be able to.
Hey, we can barely hear you. Can you talk louder?
Yeah, just give me one. Is it better now?
Yeah.
Yeah, so I would do the analysis part. So what we did was, it was very difficult to finding the data set. So this data set, I would say, is not very large. There were only, I think, 52 participants divided into two groups. One would be the control group and another is the exercise group. This experiment or the survey was ran in a hospital for like I think 6 weeks and a total of 20 hours. So what we did was we had a CSV file from all the data the survey have collected, and what we did was we first cleaned the data. I would say took out all the necessary data that we thought would be useful to uh, get a conclusion for our research. And there was a control group and an exercise group. Since control group is basically just there to set a baseline, we did not use the data for the control group and proceeded on to using the data that was for the exercise group. And I think if you zoom into the chart, it's a correlation matrix chart that we made using Python. Like we use libraries like pandas, Seaborn, Matplotlib. Those libraries we use to create this heat map and correlation matrix chart. We also did a t-test after we cleaned the data to see if there's any strong relationship between the variables that was present in the data set. So we can see in the heat map chart, there's a diagonal line that shows a very strong correlation because it's basically comparing each variable of those experiment group to each other. Yeah. So after doing the t-test, we figured out that there are a couple of variables that are, I would say, somehow correlated or like related with each other. It was not a very strong relation, but still better than some other ones, which are the variables that we used to further assess if there's any correlation between physical health, physical exercise, and mental health, are the HADSD and HAMD variable, which are like scales for measuring the depression and anxiety. HADSD stands for Hospital Anxiety and Depression Scale and Depression Subscale. And HAMD would be Hamilton Depression Rating Scale. Basically, those two variables were used for determining the depression. And there were other two variables called VO2 max and only one variable for the physical exercise, which is VO2 max. VO2 max is basically a maximum oxygen uptake by the participant, which would basically give us or hint us into the cardiovascular fitness of that person. So in the chart, in the heat map, we can see there is not much of a strong correlation between the physical exercise and the mental health, but we do find out that there is some weak positive correlation if there is physical exercise included or like done by the participants. So in the chart where there you can see on the chart on the bottom right, the upper chart, the bottom right chart, the top one is basically the data that was collected before the experiment began. So there's a slight downward sloping line of regression. So that indicates that there's a weak uh, negative correlation between depression and exercise. But at the bottom, after the experiment was done over the 6 week period, we can see a slight positive uh, correlation between those two variables, which indicates that if there is physical exercise involved, then people can have better mental health. And yeah, that was our analysis for this research. And now Dia can explain you guys about the challenges that we faced during collecting the data set and doing all this analysis.
Can you hear me?
Yes.
Yeah. So for the challenges, one of the main challenges we faced was simply finding a data set that included all of the necessary variables. It was harder than expected to locate a data set that properly captured both mental health and physical exercise data in a way that would support our hypothesis. Another issue we ran into was that the sample size in the data set was not large enough. It was difficult to get a clear picture or draw reliable conclusions from the data with fewer participants. Also, the data had a lack of diversity in terms of who participated. And again, without having a range of different backgrounds and experiences, the results may not reflect the experiences of a broader population. We also found that determining which variables influence mental health was more complicated than we anticipated. Mental health is affected by so many different factors, and the data set didn't fully account for that complexity. And all of these challenges made it difficult to fully support our hypothesis with the data we had. Now, Suman will be talking about the summary and recommendations.
Now I'd like to, can you hear me?
Yes.
So now I'd like to summarize our project. So we focused on understanding the relationship between physical exercise and mental health. Our initial hypothesis was that there should be a positive correlation, meaning regular exercise could indicate better mental well-being. We worked with a data set from ORCID, and to analyze the data, we first looked at the variables related to the exercise and mental health. We also conducted a t-test to see how strong or weak the relationship between those variables was. Then we performed a correlation test to measure how the variables were related. Finally, we visualized the result using a heat map and scatter plot. Our results showed a weak positive relationship between exercise and mental well-being, but we couldn't draw a strong conclusion. This was mainly because the dataset had some limitations. For future studies, we will also like to offer a few recommendations. Firstly, it's essential to use datasets with a larger sample size. This will help make the results more reliable and give us a better chance at drawing stronger conclusions. Another recommendation is to look for datasets that include more diverse variables. Mental health is influenced by so many different factors, so it's important to capture those complexities in the data to get a clear understanding of how physical exercise affects it. It's also crucial that the data sets include a diverse group of participants. This will help avoid bias and make the findings more generalizable to different populations. Finally, we suggest conducting more surveys. By gathering fresh and relevant data, we can improve the accuracy of future studies and ensure that they reflect a broader range of mental health factors. Thank you.
Thank you. So, questions for this team? And again, you can put them in chat or in Pittsburgh, raise your hand or just say your question.
So I have a quick question
Yeah.
about the data set. So the variables that you have, all of them, they were quantitative variables.
Yeah, so all the variables we had were quantitative variables. We did not have any kind of categorical variables in this experiment, in this survey.
Okay.
I think we have a question here that says, why do you think it was, wait, no, that was last time.
So until you find it, I have another question. So have you considered any other variables that you could use in your analysis?
Yes.
Some other factors that they may affect, any confounding variables in this setting?
Yeah, we did think about using some other variables such as weight or maybe BMI to track if weight does have any effect on uh, mental anxiety. But then the scales that we used to measure anxiety and depression levels, those did not have any kind of positive or very strong negative correlation with weight or BMI, which is why we did not include those variables in this report.
Did you also have information about age, about, I don't know, income, like factors like this? No?
For age, we did have the information, but for income, we didn't. It was a small group of 52 high school students,
Oh, high
and this
school.
data,
Okay.
yeah. So this data was very difficult to be found, and it was like more of a private kind of data that was not. They were like you can only use it for personal research. That's why it was very limited uh, when it comes to variables. So they had age and they took all the readings, such as any kind of anxiety or depression scale, and the regular variables such as weight, their cardiovascular fitness, and all that stuff.
And you have another question in the chat?
So there's one question I see. Were there any results you found that were unexpected or
No,
that
that's
surprised
from
you?
the previous. Oh, never mind. Sorry.
Yeah,
That's correct.
so yeah, we did find unexpected. We were expecting that mental health would be better, like would have a very positive correlation with physical exercise, which is true in case of older people who are like in their 40s or maybe 50s. They they do have a better correlation than younger adolescent people, and that's why uh, it was very interesting for us that we tried to find a positive correlation, but we're not successful enough to get a very strong correlation among for these high school kids.
So I would chime in to say that the Center for Disease Control, the CDC, and that website is up on the DataJam data sets page, has spent a huge amount of effort over the last few years to collect adolescent data, and there is a lot of exercise data available there. So again, I think a take-home message from this mock data jam is if you're having trouble finding a data set, then reach out to everybody that's in the class and the faculty and let us know, and we will help you look, because we could have pointed you toward a much, much larger data set. I think it's a fantastic question, but clearly you recognize that you really needed a bigger data set to look at it. And this is a good thing to learn from this mock data jam project.
I have a follow-up question. So you apply also regression in this setting?
A regression.
Yes, we did.
So you did, right? So you're
Yes.
trying to see how mental health affect or influence the exercise, right?
Yes.
Or how, but how
I
do you know,
think they were interested in how exercise influences
how do you know the
mental health.
direction?
But that's exactly what I was going to
yes,
ask.
like how do you know about the direction? So how do you know that if you are mentally feel better, then you're gonna exercise, or it's the exercise that makes you feel better? So
Yeah, so how this survey started from what I found was
System
it
on.
was So they had 52 students, 20 were in control group, and another rest of them were in the exercise group. None of
Okay.
them had any prior exercise routine or anything. So they took a base data at the beginning. They took their scale, all the variables like these HADSDs, those kind of variables. And I think the most important is the VO2 max because that indicates for cardiovascular fitness. And after all the data was taken, they were given a exercise routine for like every week they had to exercise for 3 or 4 times, which in total during the span of 6 weeks was like 20 hours. And after that, they did another reading of all the data. And that's, I think, how we can correlate that if they did the exercise, their readings like changed a little bit, like they were feeling less anxious or like less depressed based on the scales that they were using in the survey.
Okay, I think so that we fit everybody in, what we're going to do is close this discussion. But before we do that, I want to give you a really strong positive feedback on the design of your poster. You did a spectacular job. And I can tell you from years of listening to judges on DataJam, they would have loved this. The hypothesis, the data set, the analysis is really, really clearly demarcated, and it's easy to look at the poster and know exactly where to go to find the information. I think everybody wants to keep this poster in mind because this is a poster where the design judges would have loved it. So nice job, guys. Okay, do you want to stop sharing your screen in New Jersey? And do we have another Pittsburgh group that would like to go? Okay, come on up. We'll do one more poster and then we'll take a 5-minute break and then we'll keep going.
You can go.
Okay. We have a team here. Let me just. Okay, you want to pull yours up? Do you want to pull yours up?
One of our group mates isn't here today. Should we just present that?
Yeah.
Okay.
Okay. Do you want to pull your poster up? Is it this one here?
Yeah.
Okay. There you go. Okay.
All right, so we did a poster and project on investigating the relationship between obesity rates and the number of fast food restaurants per zip code in Allegheny County. And then we kind of went even further with that and like looked at the density to try and control some of like the area of the zip code and like how big it is, because obviously we thought that might play a factor into it. So does someone want to start? I can.
So, mainly like why we wanted to look into this issue in the first place is just like to kind of identify just like potential correlations between what we see in terms of health conditions in Allegheny County and then what we might attribute to like a potential cause or like a factor that may play into it, such as fast food restaurant density, just like how many exist per zip code in Allegheny County. And again, touching on that, we thought that these findings might be helpful for healthcare providers and how they might want to identify just like causes of their like patients and their potential reasons for why their health is the way it is. We hypothesized that we would see a weak positive correlation between obesity rates per zip code in Allegheny County and the density of fast food establishments per municipality. As for our methodology, like how we went about this, we used 2 data sets, one of them being showing the fast food establishment data, and that just showed how many existed in Allegheny County per zip code. And then the other one was the obesity rates per municipality in Allegheny County, and that was taken from the 2010 census. So a major part of our process was to clean the data because there were some discrepancies between the two. One of them was based on like municipality, while the other one was based on zip code. So we kind of had to use a map to identify where those zip codes were and how they like what like district or town or whatever, like what their corresponding zip code was. So one of the issues actually was that some of the municipalities listed had multiple zip codes. So what we had to do was kind of clean through the data and get rid of those points because there would be discrepancies between just like the data that we had for fast foods per zip code and the municipalities because they just wouldn't have points for that. So once we did that, we obtained a random sample of 36 municipalities, and which are now then associated with their respective zip codes and their corresponding obesity rates. So that's what we see in this graph right here.
Yeah,
So our
there you go.
first graph just has like the comparison of like the number of fast food restaurants versus the obesity rates. And so, I mean, we can actually see there's a negative correlation, which we were kind of all surprised by. We kind of expected, it was weak, but we did definitely expect it to be more positive leaning. So we were definitely shocked by that. And then the R squared value is very, very, very low. It's about 0.1 after rounding. So very weak, not really any significant correlation. And then even we thought maybe by adding dividing by the square miles of each municipality that we had, that would maybe increase the R squared value just because it'd be controlling for how big the municipalities are, because some of them are only like half a square mile while others are like 11 square miles, so there's huge difference in how big they are. But even that didn't really impact like the significance of it. It only went up to 0.11 roughly, and it's still a weak negative correlation. So we were kind of, I guess, just surprised by one, it being negative, and two, the density not really having a huge impact on how significant or how much how big the R squared is. So, and then as far as challenges, the biggest challenge was just cleaning the data. I mean, it was very messy. As we kind of already said, with like the municipalities overlapping with different zip codes and it being broken up in different ways. And then also when I was cleaning I believe it was the obesity one, it was from like a census. And so a bunch of municipalities were listed like multiple times. And so there was kind of a decision needed to be made where like, would we just like delete these repeated values? But they weren't really repeated values because they were different. So we just ended up like averaging them because that's the best that we could do with what we knew. So basically the biggest challenge was just trying to deal with cleaning the data and like aggregating two data sets that didn't really match. And so I think going back, maybe we would try and find something that maybe matched a little bit better to be able to work with our stuff better. But
so, like with the conclusion, clearly we see that negative correlation. As for recommendations, we're obviously not going to recommend that you put more fast food restaurants in an area. More likely, we would try to look for different causations for obesity, like income, or, I mean, we could go another route with like the amount of gyms in an area, affordability. So it was completely the opposite of our hypothesis, and I think a lot of that had to do with, like we said about the challenges, municipalities having multiple zip codes, stuff like that. So a lot of places also had like between 0 and 5 fast food restaurants, and then you can see like some of them had like 40. So it was a large amount, and there were extreme values in our data.
Thank you. So questions for this group? Yeah.
What other confounding variables do you think could have affected the results? Because one thing I was like thinking is maybe like in more urban or like denser neighborhoods around Allegheny County, there just is going to be more restaurants just because it's denser. And then also the people that live in those areas are going to tend to walk more, bike more, and just maybe be more healthier. What do you think?
I mean, I think there could be a lot of confounding variables. I mean, you depending on how you could like measure certain things, like maybe like the walkability or just like accessibility to like walking and bikes and stuff like that. Even, I mean, I know like obesity is like very health related or like even like genetic and like just like ancestral. So like it could depend on different aspects relating to that and more like biological reasons. And diving further that just like different like medical conditions can lead to that. So I think there's like a lot of different pathways you can take with like confounding variables, whether it's like biological or just like city, what the city looks like.
And even like with the type of restaurant, because you could have something like Roots, like a salad place, versus like Chick-fil-A. One of them is obviously for you. So that also plays a role into it that we could potentially like look into.
And you have a question from Chris Vilicki. I think you may have started to answer it, but he says, did you happen to see the presence of rec centers or gyms or open fields? And did you look at different zip codes in the country, or did you just stay in Allegheny County, which may be more homogeneous? I think what he's getting at is, did you look at diversities of places?
We just kept to the Allegheny County area because we just got our like data from like the Allegheny County like data center thing website. So that's kind of where we got all of our information from. We didn't like take anything anywhere else like in the country. It was just from like Allegheny County.
And they didn't have rec centers or
no,
parks?
It was just strictly the one data set was pretty much like obesity rates or like obesity rates, and then the other one was strictly just like fast food restaurant zip code, and then like it had a couple other information like more specifically like the address of it and stuff like that, but there were no like we didn't look at additional like rec centers or stuff like that.
And Christian Severin says, did you find cleaning the data to be difficult in terms of zip codes and counties? And I think you did say that was a huge problem. Do you want to say anything else about that?
It was just really time consuming because we didn't have a data set to put that together. So it was just like looking at maps, looking on the internet about what municipality goes with what zip code. So it was just really time consuming with our sample starting at 50.
So this is an extremely common problem, and you will run into it with your DataJam teams. I mean, they want to use multiple data sets, but the data is organized by zip code, by county, by municipality, by census tract, and none of these things nicely overlap with each other. And they're going to have to come up with strategies for doing that, just like you did. But there's no way around that. It's hard to find data all in one set that's organized the same way. When you're looking at, does this variable influence that variable, you frequently have this problem. But it's a really good thing for students to learn too. And so they'll struggle, but they'll learn something by struggling.
So follow-up question. So at some point you said that you random sampled the 36 municipalities. Do you mean that you ended up with those 36 municipalities? What do you mean you random sample them?
Yeah, so there's like about, I think, 100-ish like municipalities in Pittsburgh, and like we already knew that it was going to be super time consuming to try and match them up to like how they were. So then we took we like literally just used like based on like
how did you choose those?
Yeah, we just like looked up like a random number generator and generated like 50 like however many numbers we needed, and then based on like the Excel number that it was in, we just like took it out to use it.
I see. Okay.
Any other questions?
Out of curiosity, did you check the areas of those municipalities that you ended up using? They were well representing the county, or they were maybe biased on one direction or another? Because you may use random generator to get some municipalities, but maybe you're very unlucky and you ended up just in one area of Allegheny County?
Oh, no, we didn't. We just took the random number.
So
Yeah, we
something
didn't
that
look
we
at
do.
different
That's
areas.
kind of like a valid point. I feel like if we were to do this moving forward, we take multiple random samples and see if there's like a general trend, like if the R value was equally as low across all those samples.
So, what do you feel like your take home message? What did you learn from this that you can imagine you're going to apply going forward? I mean, I think how do you mesh data organized differentially is huge. Were there other things you think you learned from this?
Yeah, definitely meshing data. I think also maybe looking at multiple different data sets to see if we want to change our hypothesis with like instead of going the fast food route, we could have went income or something else. So just looking at a lot of different data sets to choose which one.
Yeah. One thing that occurs to me, and it occurred to me in the very first presentation also, looking at Oakland mental at homelessness and how much money was spent. Very frequently, especially for the high school students, but also for the community college students and also for you, you have a hypothesis that the relationship is a particular direction, thinking that, for example, in the Oakland situation, that if more money was being spent, homelessness would have got better. It would have gone down. Here you're thinking if there's fewer fast food restaurants, obesity would be less. But it's very likely that obesity is high because, and there's a lot of fast food restaurants, but that there's other variables that are influencing this. So the relation, it's not a causal relationship in the direction that you were expecting it to be. So almost everything that you're going to have DataJam teams working on is going to be multifactorial. They may only choose to look one aspect of the relationship, but the reality is there's practically no sociological issue or question that you can ask that is not multifactorial. And so as a mentor, you want to kind of prod them and start getting them to think about, well, what else could be going on here? And sometimes that takes a lot of prodding. I can just say from experience that especially at the high school level, they get attached to their hypothesis and it's hard to change their mind, which is why data analysis is so good and why it's good that they learn it, because they kind of prove to themselves that they should have taken a broader approach. And them doing the data analysis will prove it much better than you saying it. So I've had many, many mentors over the years say they just wouldn't listen to me. But then at the end of their project, they were like, oh, I bet there were other factors going on here. But I think that's why, that's the power of DataJam. And you should feel really good about being part of this. We're going to take a 5-minute break and we'll come down back and let's move on to another presentation in San Francisco. Okay.
I got it. Sorry.
Excellent.
Hello, everyone.
Hi. Okay, you guys can go ahead and start. Introduce yourselves, and everybody should do that at the beginning, because although you see your names on email lists and people know you're familiar, just being able to match your face with the name is really helpful.
Hello, everyone. My name is Christian.
Hi, my name is Rizu.
My name's Chris.
Hi, and my name is Shashwat.
All right. Hello, we're from Caldwell, and today we're going to be presenting our project, which is our topic is remote work versus in-person work, productivity across different industries in the United States of America. So today, in our brief summary, in regards to our project, we noticed that during COVID, and post-COVID, in the post-pandemic world, businesses have adopted a different business models of remote and hybrid working patterns. Determining if there's a correlation between working remotely and recent productivity trends helps the business owners understand what model of working is best for the success of their company. So seeing that, we decided to uh, try and find some data to see the correlation between remote and in-person work in regards to productivity. Our high In regards to our hypothesis, we hypothesized that working remotely has maintained or improved productivity levels in most industries when compared to in-person work. So we have uh, presented this data through our different data visualizations in our graphs as well as through the t-test and the regression analysis. Uh, my teammate here is going to take over.
Okay, so now I'm gonna interpret the charts that you see, like the chart number 1, 2, and 3. So chart 1 displays the comparison between remote and in-person work in terms of productivity measures. It highlights the mean, median, and the standard deviation of productivity scores. As we can see in chart number 1, we can see that remote workers have high mean and median productivity compared to in-office workers, suggesting that the remote workers have higher productivity. We can also see a huge gap in the mean of the productivity scores in terms of remote and in-person workers. The mean score of remote workers is around 73, and in terms of in-person is just around 64.85 or 65. And moving on to chart number 2, we can see that chart number 2 is a bar chart that further breaks down productivity scores. The lack of outliers in the box and whisker diagram supports the hypothesis that we just made, that remote workers maintain or improve productivity, as it indicates a stable and consistent level of performance across employees. We can also see that the higher productivity levels are consistent among the population, as indicated by mean and median. And moving on to chart number 3, the chart number 3 is about the well-being scores of remote and in-office workers. The well-being average chart shows that higher mean and median well-being scores for remote workers in comparison to in-office workers, supporting our research. And hold on. We can see that the standard deviation of remote workers stands at 11, and for in-person person stands at 15.97, which shows that there's less fluctuation among the remote workers in terms of well-being, which is good for our hypothesis or for our topic of research, as it indicates that remote workers are relatively less and they are more consistent in their well-being in compared to in person, as the data is more fluctuated in terms of their well-being. So moving forward, I want to pass on to Rizu, who's going to discuss the t-testing and the results and the further analysis.
Thank you. So for our project, we also decided to move on with a t-test so that we were able to compare the mean productivity levels between remote and in-person work environments. So the basic goal of this test was to determine if the difference in productivity that we've seen from these different kinds of graph have any statistical significance. So here you can see the result that we got from the t-testing, and we got a p-value of 8.41 e to the power of -8. So to convert that into understandable numerical terms, that would be 0.70 and then 841, so which is very close to zero. So that does go ahead to indicate that the findings that we made were statistically very significant, which proceeds to support our hypothesis that remote work maintains and even improves productivity as compared to in-person work. We also were able to do a t-testing for the well-being score that we weren't able to include in the chart because we didn't have enough space, but just letting you guys know, the p-value that we got from the t-testing for the well-being was 1.85 e to the power -0.8. So basically converting into numerical terms, that would be 0.70 1 and 5, basically, again, very close to 0. So that means that it is very significant, and the higher the people work remotely or the more remote work, well-being increases among the employees. Secondly, we chose to do a multiple linear regression because we wanted to identify whether productivity is being impacted by variable other factors too. So for our analysis, as you can see in the regression statistics, we chose the variables such as monthly salary, training hours for employees, how many projects they were handling, overtime hours, sick days, work hours. So based on that, we wanted to find out what kind of variables have higher impact on the productivity. Of course, the dependent variable being productivity rate. So what we ended up finding, as you can see, the R-square value is 0.26. That means that 26% of the variability in productivity is explained by these independent variables. So although it's not very significant, that does show that apart from the work setting like remote or in person, there are other variables too that does impact productivity scores. There are two particular variables that have been highlighted here. The green one, which is the monthly salary. So for the monthly salary, it had a high t-statistic, 187, and a p-value of 0, which means that it had a very strong positive impact on productivity. In simple terms, it indicates that the higher the monthly salary, people are more likely to be more productive. The second variable that we have highlighted were work hours per week. So that has a negative coefficient of minus 0.0017 and a significant p-value of 0.0137. So this shows that it is significantly important, but the work hours decreases the productivity rather than increasing it. So it has a negative correlation between them. The other variables in there, such as training hours, project handlers, and sick days, were not statistically significant. So I didn't really highlight that. But overall, we can see the significance F is 0. That means that the analysis that we've been doing has a very high statistical significance, which goes on to then support our hypothesis. So basically, all these analysis does reveal that remote work positively influenced positivity as well as well-being among the workers. Now, let's proceed on to the challenges that we face as well as our overall conclusion. Christian is going to take over.
Yeah, thank you, Rizo. Appreciate that. So just to reiterate our conclusion here, just that we found based off of our analysis that it was either, that remote work increased or maintained the same levels of productivity. I'm hearing myself twice. Is that coming through okay?
We hear you just fine.
Okay, gotcha. I'll just roll with it. Sure. So that's again, like Rizu had already stated, our conclusion there. But as far as challenges that we encountered, was just in the area of the data sets primarily. As we were looking at Bureau of Labor Statistics data that's freely available. They have zip files that have a variety of different file types that you can download. They give you this accurate freely accessible data. But the problem that we were running into is trying to convert that into like a CSV file, Excel workbook file, to enable us to easily run analysis and run the regression analysis as well. So that took a little bit of time, and that was a bit of a hiccup. Going forward, we'd prefer to analyze data that's more clean and easy to use in our home programs, especially as we try to use programs in the next project. With Power BI and Tableau and that sort of compatibility there. There's just one other hiccup along the way, was just the brevity and the size of the data by comparison. So for the Bureau of Labor Statistics, this is coming from American Time Use Surveys. And so we found reports that generated over 100,000 rows and responses, according to that. And so trying to, find a actionable insight from the 100,000 results proved to be a little difficult. And so we did use random sampling to assist us in that, as mentioned before, we do have a variety of factors that were included in that response data. I know I'm rambling, I apologize. But something worth noting is that they gave a performance score that was rated from 1 to 5. So we didn't include it here in our analysis because if you were to generate the average between 1 through 5, where you can only give whole numbers, trying to find the difference statistically over the sample size that large wouldn't yield any results that would be interesting to look at. So without further ado, I'll thank you guys for your time and open up to some questions.
Great, thank you. So questions? Yes.
Is that data set representative of different type of companies? Do you have such access? Let's say not all of them are maybe tech companies or stuff like that.
Yeah, no, that's a great question. So actually through that Bureau, and I'm going to let Harizu answer this right after, but through the Bureau of Labor Statistics, we actually have data based off of department or industry. And so, Harizu can speak better to the challenges that we encountered there in a more succinct way. But basically, yes, we did take into consideration the different industries as best we could. Harizu, I'll kick it to you.
Okay, so basically we worked with two major data sets. So one was like an average of all the US industries that they surveyed. And there was one data set that was differentiated by industry, and we still have that. That was the data set that was over 100,000 rows. So what we did was we first categorized them based on the department. Then we created a different column that we assigned random numbers, like using the random function. So it assigns a random variable between 0 and 1. We pasted that throughout the whole data set depending on the department, and then we sampled the top 17 for each of the department. We had that data set, but because of the time restriction, we couldn't do further evaluation on that. So we did decide to stick with just like a general overview of it. But like for future, if something like this is worked on, like it would be very useful that every single department is analyzed separately to see what kind of standard deviation or what kind of fluctuation in productivity they have based on the department. But because of the intensity, because it's a lot of data and we didn't want to like omit a lot of data so that we get uncertain answers. So we, even with 17 data sets from each of the department, we were stuck with over 500 rows of data. So that got too complicated for us for the project. So we just decided to stick with the general survey of the entire department altogether.
Thank you. Other questions? Or questions online? I'll just note that again from a DataJam presentation mode, I love the numbering of the graphs, and the judges would love that numbering too. So really nice job. Everybody wants to learn from these things. They would have liked to see you have a section that was clearly the conclusions and clearly the challenges marked, but numbering was great.
Thank you.
Okay,
Thank
I
you,
thank
everyone.
you very much. Why don't you stop sharing and we'll move on to the San Francisco group. And again, please put your camera on while you're speaking.
Hi, can you hear me?
Yep.
Okay, wonderful. Let me just share my screen. Um, okay. Oops.
Excellent. We can see it.
Okay, great. I'll zoom out for a second just so everyone can see the overall big picture. Oops, that's too small. Okay. Here, okay, here. All right, so the project that I did for this mock project is assignment is to look at the relationship between average income level. I'm sorry, this should be median income level and urban tree cover in San Francisco. And so the research question I looked at was the relationship between the income level of neighborhoods in San Francisco as well as the percentage of tree cover in that neighborhood. And my hypothesis was that neighborhoods with the least tree cover have more residents at or near the poverty level. And on the other hand, neighborhoods with higher median income levels would have higher percentage of tree cover. And for my data sets, I looked at the San Francisco Urban Forest Plan for tree cover data, specifically the percentages for the different neighborhoods in San Francisco. And I also found an SF Chronicle article which detailed median income levels. This is data taken from the US Census Bureau. And so I decided to use that data. The reason why I wanted to do this research project was because of the increasing levels of heat and extreme weather events. And heat kills more people than any other extreme weather event, from my understanding. And just looking at some of the research on this in general. And so this is a problem that we're seeing, especially in California. Like this week has been really, really warm in San Francisco, for instance. And so I used Excel for my data analysis. I created a bar graph. Zoom in a little bit. Oh, I'm not doing too much. Let's see. And so what I did was I laid out the median income per neighborhood, and I also added the neighborhood next to each bar to make it a little easier to see the categorical data. And then my y-axis is the percentage of tree cover. I also ran a logistical regression on my data and saw that there was a positive correlation just in terms of the slope and everything. And again, I apologize. This axis should be reversed, but as you can see, I'm sorry, the x-axis should be reversed, but as you can see, the higher the income level, the higher the percentage of tree cover, and then the lower, the less percentage of tree cover. Yeah, and just in terms of my analysis, overall, I saw a weak positive correlation between income level and tree cover. The results I noticed were statistically significant because the p-value was 0.026. And one other thing I just noticed from looking at the pie chart, I also made a pie chart just to see the distribution of tree cover per neighborhood. I noticed that 29.4% of the tree cover in the city was in neighborhoods with income over at $200,000 or more per year. And so in terms of some of the challenges, I was initially hoping to look at tree cover and income level throughout California, but I found some difficulties finding data with this particular information. And I noticed that not all parts of California have data on this subject. And so San Francisco has a robust urban tree planting program. And so I decided to narrow the scope of the research that way. And also one other thing, while the census data did show that the neighborhoods question had over 200,000, like the residents had a median income over 200,000. It didn't specifically say how much more. And so I had to deal with the plus symbol, and in order to come up with the visualization, I removed it to be able to make these graphs. So, and then also this was a smaller sample size, and I do want to acknowledge that, and this would be a good pilot study, I think, if not a study that would determine, the relationship between these two variables overall. But given all these conditions and circumstances, I did find that the hypothesis was correct, and there is a relationship between median income level and the percentage of tree cover. And in terms of implications, again, this research and data might be helpful in terms of addressing any systemic inequalities between income and climate change. And it may be useful to inform policy decisions, especially as the climate crisis gets worse. I think that's all I have to say on this. Thank you.
Thank you. Very nice. Questions for MJ? Yes.
Have you considered any other variables that they may affect the relationship between these two?
I thought of population also, as well as considering longitudinal variables as well. So, but for the scope of this assignment and the time given, that would be a good thing to explore for a more long-term assignment. But I did think about it, but intentionally decided not to choose it for this assignment.
So you mentioned that originally you were thinking of looking across California, but that a lot of places didn't have this kind of data. And that, I really want to highlight that aspect because that's frequently the problem that DataJam teams run into. They think, oh, they'll look at every county in a state or something like that, but there isn't that data. An alternative to just looking at one place, though, is to look at another place. So you could have, for example, compared San Francisco to Los Angeles. They're both big urban centers. My sister happens to run the tree planting program for Los Angeles County, so I know they have this data. But frequently teams want to look more broadly, but they can't find it for everywhere. And what all of you want to advise your teams is you don't have to look everywhere. You don't have to have all the data, but it can really make your evaluation of things much more robust and meaningful if you pick several places. Another possibility that occurred to me listening to you was I would think whether a place is rural versus urban would make a big difference. And you wouldn't have to have all the urban and all the rural places to do it. You could have a couple of each and start to get a feel for that. So getting the students that you're mentoring to start to think about what is their question, what are the variables they want to look at, and could they do it by very thoughtfully choosing some data sets to look at is a good idea.
Yeah, that's all very helpful, doing a comparative analysis. Thank you.
Yeah, and you have a question on chat from Paige who says that pie chart was a great visual. So she really liked the pie chart. And I can tell you, judges love charts. And they love colorful charts. So that is certainly something to keep in mind. Any other questions?
You can see us. My name is Justin, and I'm from San Francisco.
And my name is Katya, and I'm also from San Francisco State University. And our topic is youth mental health in America. And our research question was if there was a correlation between lack of service, mental disorder cases, and substance use. So our hypothesis, we hypothesized that in the United States, higher number of young people ages 12 to 17 without access to mental health care services will experience higher numbers of substance use cases. Furthermore, we expect a direct relationship between untreated mental health conditions and increased substance use rates, as untreated medical disorders often lead to coping mechanisms like substance.
So just to clarify, basically we're researching 3 different topics. It would be the lack of access to service for mental health services for the youth, as well as mental disorder cases, and then substance use for youth. Everything is for the youth. So why is this important?
Can I interrupt for a minute? We can't see, there's 2 screens up on your screen. I think if you just say present, you hit that purple button, then we'll be able to see the poster full screen. Yes, nice. Okay,
Like,
go on, I'm
can you
sorry.
see it now?
Yes, yes.
Okay, so why is this important? The growing number of mental health problems among youth in America, along with limited access to treatment, is a serious issue. When young people can't get that help they need, they may turn to substance use as a way to cope, which can cause more harm. Understanding the connection between lack of services, mental health conditions, and substance use can help policymakers and healthcare providers focus on the needs of youth and fix the gaps in mental health care.
Okay, so for our analysis and kind of how we collected our information and how we analyzed it. So first, all of our information is coming from the Mental Health America's 2023 Youth Data Report. And now in this study, there was multiple categories, and we only selected a few, being lack of service, mental disorder, and substance use. And the data kind of is in the form of just amount of cases per state in the United States. So using this data set, we were able to develop graphs in Python, and then we used Python to kind of analyze it using various libraries such as Seaborn and Matplotlib. And so here now I'll show you the graphs that we came up with. Can you still see it when I zoom in?
Yes.
Perfect. So our first one right here is the correlation between no service and mental disorder with substance use. So as we can see on our x-axis, we have the number of no service cases. And so these are, again, just the amount of people who have a mental condition but did not receive any help for it. And then on the y-axis, we have mental disorder cases. This can be anything from depression. There's really no level on that, which is something that we can talk about a little bit later with the challenges. And then so each point on this graph it's plotted with substance use. So each point is an amount of substance use, but then it's on a scale of varying from, smaller to larger, also with a lighter color to darker color for the amount. As you can see, this red one right here, this one would be our highest amount of substance use cases. And also you can see that we have a regression line. And then also there's some black shading with the regression line that shows the 95% confidence interval. And yeah, once again, this was created in Python. We used, So for this next one, this one is a correlation heat map. I think one of the other groups kind of had one of these earlier. So again, this is just to better visualize the correlations between our three variables here. So the way we kind of read this is, if we take a look at the bottom left square, for mental disorder and no service, there's a correlation between those 0.86. And then if we keep following the rows and columns, we can see that, for example, substance use and mental disorder was 0.98, which is pretty high. And then obviously, if we keep following up the left side, the very top, mental disorder and mental disorder is a 1 because they are the same thing. So that's kind of how we read it. And then we also made it, since it's a heat map, we had it with kind of going from cold to hot, as in a lower correlation to a higher correlation. So using those graphs, let's just talk about our challenges and limitations of what we had during this project. First of all, I would say that one of the bigger ones was that we could have definitely used a lot more categories and variables. Also, this project, we actually started it out. We were trying to make a machine learning model at first. And, if anybody's familiar with that, one of the biggest things about that is we need to have, a lot more data. So if we had a lot more data, then we could have gone through with it better, but we kind of stopped that because we didn't. And, other factors we could have done were socioeconomic, like income level, and even like ethnicity as well. Also, this is from 2023, so it would be nicer to have maybe even a wider range of like years for the data, or even just more recent. And I think that also with this project, we've left a lot of room to add to it in the future if we wanted to, and even kind of go back to the original plan of making a machine learning model. So moving on, what did we conclude? We concluded that our hypothesis was pretty much correct, as you can see from the graphs. There is a positive correlation. There is a direct relationship between mental health disorders, not getting help, and substance use. And yeah, that's pretty much it.
Thank you. So, questions?
I have a clarification question.
Yeah.
So what are the variables that you're studying? So I'm not sure what do you mean by no service cases.
So when we say no service, it's pretty much the amount of people who have a mental disorder or just are in need of help that did not get help for it.
So that means they didn't get any kind of help.
Like whether it was provided through school or outside of school through insurance, yeah, no type of that.
Okay, but they could have had access to health insurance, but they didn't choose to access it? Is that what that means? It's their choice?
It's more specifically, it's more of they don't have access to it. Like let's say they're in middle school and there's no like kind of therapist or counselor that checks in with students who are experiencing things.
Right, so that's different. That means they aren't in a situation where anybody is there to serve them. So it isn't their choice to get no service. It's that there's no service available to them. And how big was your data set? I didn't get a real sense of that.
Yeah, so if you can still see the screen, I'll just show you. So after kind of importing it into Python, it pretty much looks like this, and it goes all the way down to obviously all the 50 states, and then it's just pretty much 50 per category. So yeah.
So it was by state, and you're looking at drug abuse, and you're looking at mental health disorder by state, and the no service is also by state then? So it's the percentage no service?
Yes, everything is by state. There were percentages, but I decided to just use the number of cases. So I can see why that's like a little confusing.
And you only chose the ones with no service? I'm just having trouble understanding how about for the one, did you look at individuals who did get service?
No, I did not.
Okay, I understand.
Yeah, so it was strictly just if you had a mental disorder, if you didn't receive service for it, and then if you used any substances.
Do you think the population of each state may impact or influence basically the numbers that you get?
Yeah, that's a good point, because obviously in states that are smaller, the numbers are definitely smaller. That's why if I were to add to this or redo it, I would definitely kind of scale it. So using the percentage of the population by state, just so we can get a better idea.
What year was this done in? Like what year did you gather the data from?
Last year.
last year. Okay.
Yeah, we have a question over here.
Yeah, for the machine learning, how would that work for this type of data set? How would you do that in Python?
So pretty much, okay, let me try to get just a short summary of this. Essentially, we would kind of have to pre-process this data. We would have to collect a bunch of data, and kind of like how I set it up in this table right here, we would then cut pretty much, this is so hard to explain, but you have to separate our chart into labels and features. I kind of did that actually, but I didn't end up using it. So you can see like right here. And so basically we would, for example, what we were trying to actually be predicting would probably be more if they use substances, for example. So what we would do is we would drop that category completely, and then we would have to train the data using the features that were not dropped, and then we'd have to create a decision tree. We can even do random forest, and there's a lot to it, but pretty much we're just training data to get a prediction for a category or test data that we dropped.
Other questions?
I have one comment about the heat map. I think the coloring is a little bit misleading because there are some ones that are darker color but actually have smaller correlation compared to other ones. So 0.86 has lighter color than 0.79. So maybe because all of them are positive, just keep the same color, either red or blue, but just go from darker to lighter or from lighter to darker.
Mm-hmm.
This would be maybe more like informative. Yeah.
Yep, that's a good point. Any other questions?
I don't see any questions online.
Okay.
Well, thank you very
Thank
much.
you very much.